All right. Well, I think I'll go ahead and get started. Good morning, everyone. So my name is Brian. I'm one of the grad students here. I'm helping to organize the statistical learning group this semester. So we're kind of kicking off the talks today. As Neil mentioned last time, we're going to try to cover 3 different topics this semester. For each one, we're going to try to do a big picture talk, followed by 2 more technical talks. So I'm going to kick off the little mini-series on regularization today. So I'm going to do the big picture overview talk. As a disclaimer, the level of difficulty is going to change. So the idea with this talk is that it's going to be accessible to everyone. So even if all you've taken is an intro to stat course, if all you've taken is 311, you should be able to get something out of the talk, at least some of the main ideas, some of the concepts. But there are going to be times where you maybe don't completely understand everything. At the same time, if you're a stat grad student, there are going to be times you're probably going to be bored and be like, oh, I learned that years ago, but just bear with me. You're also going to get something out of the talk. Going forward, so Josh Day is going to be giving a talk next week comparing some of the different regularization penalties. And then after that, we're doing another talk on regularization, but right now I haven't been able to successfully recruit anyone to do that. So I'm definitely looking for volunteers. If anyone wants to do that, even if you're an undergrad, you're applying to grad school, having this under your belt, having this on your CV would be great for your application. So don't be scared of doing it or feel like you don't have the qualifications for it. Another thing on the group, this is the first time we're doing it, so if you have any suggestions on ways in which it can be improved throughout the semester, please let us know. And also another thing, one of the points of the group is to give people practice presenting this material, and so I definitely am interested in trying to become a more effective presenter. So if there are any suggestions you have for me, please let me know. If you want to put it in my mailbox anonymously and be harsh, I'm open to that. So just, I guess, let me have it. So the game plan for today's talk, I plan on talking for maybe 35, 40 minutes, kind of have a lot to cover, but we should hopefully have a little time at the end for some discussion, some Q&A, but if along the way, if you're stumped on something, feel free to stop me and we can address it on the fly. So here's my game plan. I'm first going to just review some of the stuff that Justin talked about last time, cover some of the basics, some of the notation. Then I'm going to spend quite a bit of time just motivating on why we even care about regularization, why we would ever want to use it. Then I'll kind of get into the framework of it before actually discussing some of the details with implementation and actually working through a data example. Are there any questions so far before we kind of get started?
Can you move the mouse pointer out of the way?
Oh, yeah, sure. All right. Anything else? Yeah. Yeah. I think we're stuck with that. So regularization falls under the umbrella of supervised learning, which Justin covered last time. And really the main idea with this is that we're going to observe both inputs and outputs. And what we're trying to do is just build some sort of model to understand the relationship between the two. Often we're going to be primarily interested in prediction, but that's not necessarily the case. The key thing that really just distinguishes this from unsupervised learning is that with unsupervised learning, we don't actually see the output, we don't supervise the output. So here we do get to see both, and we're just going to try to build some sort of model to understand the relationship between the two. So before we kind of get into actually finding that model, just to set up some of the notation, it's pretty standard. So y is just going to be our output or the response variable. The I subscript is just going to correspond to which observation we're actually dealing with. Xij's, those are going to refer to the different observations of our predictors. So the J subscript just corresponds to which predictor or which feature we're actually dealing with. Those of you who've taken any sort of advanced stats will know that it's a heck of a lot easier usually to deal with this stuff in matrix notation. So that's just going to generally be represented using the bold symbols there. If you haven't really used matrices before, understanding this is not necessarily crucial. You can really just think of this as sort of a mathematical representation of our data. So we're looking at our data sort of on an Excel spreadsheet where we have our observations in rows and our variables in columns, and then we're just mathematically representing it with our data matrix X there. One kind of side thing that comes into play when dealing with regularization is that before we actually implement our methods, we want to standardize our predictors. This is going to be done using just the classic z-score that people should remember from Stat 311. The point of this, it's the same point that we even do it when we're doing the z-score formula in 311, is that we're just trying to put everything on the same scale. It'll become a little more obvious why we do this later when I get into regularization, but just to kind of keep the notation consistent without, just to make you aware of it. Once we do the standardization, it's kind of nice because then for our intercept, this beta naught hat, we can just set that to the sample mean of our response, and we just have to go through and estimate the rest of our coefficients. And then at the end, if we want to transform back to the original scale, which is probably going to be more interpretable for what we're doing, we can always do that. So when it comes to what we're trying to do, our goal is, again, we're trying to understand the relationship between x and y. So given our data x, we're just trying to find some sort of function of that data to model or predict our response y. And as Justin talked about last time, we're usually going to do this in terms of a loss function. So this is just going to be something that's going to measure the adequacy of fit, how well does our model actually fit to the data. By far the most common loss function is going to be the squared error loss function. And then to actually find f, common thing to do is that we're just going to minimize the expected loss. So on average, what is our loss going to be between the data and the response? And if you kind of work through the gymnastics of this, you're going to find that the function that minimizes this is just going to be this conditional expectation. So given the data that we observed, we just want to look at the conditional mean of what our response is. Are there any questions on anything so far? For linear regression, that's where we're going to look at this conditional expectation, and we're just going to assume that it's going to be a linear function. So this is just going to give us the kind of the standard multiple linear regression that we presumably have all seen at least at some point. And with that as our f, all we really need to do now is just to go through and actually estimate those regression coefficients, and then we're going to have what our model is. To do that, again, we're just going to use our squared error loss, and we're going to try to minimize that. So we're looking at the least squares, we're looking at the OLS solution here. To do that, we just use some matrix calculus, and we can find our solution. It's going to be this beta hat OLS is given by this formula. Again, if you haven't seen this sort of thing, that's completely fine. This is the sort of thing, this is basically just what the computer is going to be doing in the background when you're finding the solution. Once we get that solution, then we just go back to, okay, what's the functional form that we assumed in the beginning? Now we have our estimates, so we just have to go through and plug in our estimates, and now we're going to actually have our estimated model. Any questions on kind of the basic setup before we get into any of the motivation? Yeah, what's up?
Can you just mention some other common loss functions that we use?
Yeah, so some of the other loss functions would be like the absolute loss. So instead of looking at the squared difference of our response in the function, we're looking at just the absolute value of the difference. Another one, 0, 1 loss, and like classification, either you got it right or you didn't. There's something called the hinge loss, which comes into play with support vector machines. So there are like a handful of loss functions that we can use, but squared error loss is definitely I'd say by far the most popular one.